The morning alarm buzzed at 4:30 a.m., just like it had for the past 15 years. Roberto rolled out of bed, grabbed his thermos of coffee, and headed to work. His job was simple: keep the floors clean at one of the biggest manufacturing companies in the city. While most people were still sleeping, Roberto was already pushing his cart down the long hallways of Apex Industries. Roberto took pride in his work. Every corner had to be spotless. Every machine wiped down perfectly. He knew every inch of that building better than anyone else who worked there. The security guards would wave at him and he'd nod back with a small smile. This was his routine, his life, and he was okay with that. At home, his daughter Lisa was just finishing college. She had spent 4 long years studying mechanical engineering, staying up late with textbooks and spending weekends in the lab. Lisa was smart, really smart. Her professors always said she had a special gift for understanding how machines worked. But now that she had graduated, finding a job felt impossible. Every day, Lisa would send out resumes and applications. She'd spend hours writing cover letters and preparing for interviews that never seemed to come. The few interviews she did get always ended the same way: "We're looking for someone with more experience." It was frustrating. How could she get experience if no one would give her a chance? Money was tight at home. Roberto's cleaning job paid the bills, but there wasn't much left over. Lisa felt bad about not contributing, so she started helping her father at work. She'd come with him in the early mornings, helping to carry supplies and clean the offices. It wasn't what she had dreamed of doing with her engineering degree, but it helped her family and gave her something to do. Working alongside her father, Lisa began to notice things. Really notice them. The building was full of amazing machines and equipment. There were testing labs, design rooms, and a huge manufacturing floor where they built engines. She found herself fascinated by everything she saw. During her cleaning rounds, Lisa would quietly watch the engineers work. She'd see them huddled around computer screens, pointing at charts and graphs. Sometimes she'd hear them talking about problems they couldn't solve. Other times she'd notice them looking stressed and tired. The company was working on something big. Everyone could feel the tension in the air. One day, while cleaning near the main engineering lab, Lisa overheard 2 engineers talking. They were discussing a project that had been giving them trouble for months. Something about an engine that kept breaking down. She didn't understand all the technical details, but she could tell they were really worried. The engine they were talking about wasn't just any engine. It was supposed to be revolutionary. A new type of hybrid engine that could change everything. The company had invested millions of dollars and years of work into this project. If it succeeded, Apex Industries would become a leader in clean energy technology. If it failed, the company might not survive. Lisa learned that the engine had a strange problem. Every time they tested it, it would run perfectly for about 47 minutes. Then, without warning, it would suddenly stop working completely. The failure was so severe that they had to rebuild parts of the engine each time it happened. 3 different teams of senior engineers had tried to fix the problem. These weren't just any engineers. They were some of the smartest people in the industry. They had years of experience and advanced degrees from top universities, but none of them could figure out what was wrong. The CEO of the company, Mr. Davidson, was under enormous pressure. The board of directors was asking tough questions. Investors were getting nervous. Everyone wanted to know when the engine would be ready. And Davidson didn't have answers. Davidson was known for being demanding but fair. He had built Apex Industries from a small startup into a major player in the manufacturing world. But this engine project was testing him like nothing before. He would walk through the building at odd hours, checking on progress and asking questions that no one could answer. The failure of the engine project was affecting everyone at the company. Morale was low. People were working longer hours but getting nowhere. Some employees were starting to look for jobs elsewhere, worried that the company might not make it through this crisis. Lisa watched all of this unfold during her cleaning shifts. She saw the stress on people's faces. She heard the worried conversations in the hallways. But she also saw something else. She saw patterns that others seemed to miss. While cleaning around the engine testing area, Lisa noticed that the failures weren't completely random. There seemed to be a timing to them. She started keeping track in a small notebook, writing down when the tests happened and when they failed. Her father, Roberto, noticed his daughter's interest in the technical work. He was proud of her education, but worried that she was getting her hopes up. "This is good work," he would tell her, referring to their cleaning jobs. "It's honest work that pays the bills." But he could see the spark in Lisa's eyes when she talked about the engineering problems. One evening, as they were finishing their shift, Lisa was cleaning around the failed engine prototype. The area was covered with diagnostic equipment, computer, printouts, and technical drawings. The engineers had left everything out, probably planning to start fresh the next morning. Lisa couldn't help herself. She started reading the technical reports that were scattered on the tables. Her engineering training kicked in, and she began to understand what the teams had been trying to do. She saw the complexity of the problem, but also noticed some things that seemed odd. The next morning brought another crisis. The latest test had failed spectacularly, causing damage that would take weeks to repair. The engineering teams were gathered in an emergency meeting, trying to figure out their next steps. Mr. Davidson was livid. He had just gotten off a difficult phone call with the board of directors. They were talking about cutting funding for the project. Some were even suggesting that maybe it was time to abandon it entirely. In his frustration, Davidson stormed out of the meeting room and began walking rapidly through the building. He needed to think, to clear his head, to figure out what to do next. His company's future was hanging in the balance, and he was running out of options. As he walked through the engineering section, he saw Lisa quietly cleaning around the engine testing area. She was being careful not to disturb the equipment, but he noticed that she was also studying the technical drawings and computer printouts. Something about the scene struck him as odd. Here was a young woman, supposedly just a cleaning person, who was clearly reading and understanding complex engineering documents. Most people would have ignored the technical papers completely. "What are you looking at?" Davidson asked, his voice sharper than he intended. Lisa looked up, startled. She hadn't expected to be questioned by the CEO. "I'm sorry, sir. I was just cleaning around the area. I didn't mean to disturb anything." "But you were reading the technical reports," Davidson said. "It wasn't a question." Lisa hesitated. She knew she could get in trouble, maybe even lose the cleaning job that her family depended on. But something made her speak up. "I have a degree in mechanical engineering," she said quietly. "I couldn't help but notice some things about the test results." Davidson stared at her. Here was someone he had never really noticed before, claiming to understand problems that his best engineers couldn't solve. Under normal circumstances, he might have dismissed her entirely. But these weren't normal circumstances. "What kind of things?" he asked. Lisa took a deep breath. This was her chance, maybe her only chance, to prove herself. "The failures aren't random. They happen in a pattern, every 47 minutes almost." "Exactly. That suggests the problem isn't with the engine design itself, but with something in the testing environment." Davidson felt a mix of skepticism and desperate hope. Could this young woman really see something that his experienced teams had missed? Or was she just making lucky guesses? The pressure of the moment, the frustration of months of failure, and the desperation of a CEO facing the collapse of his company's biggest project all came together in that instant. "You think you can solve what our best engineers can't?" Davidson said, his voice heavy with sarcasm and challenge. "Fine. You have 48 hours. If you're so smart, prove it." As soon as the words left his mouth, Davidson wondered if he had lost his mind. But it was too late to take them back. Lisa stood there, cleaning cloth still in her hand, suddenly faced with the opportunity of a lifetime and the pressure that came with it. The challenge was set. In 48 hours, a young woman with no professional experience would either solve one of the most complex engineering problems the company had ever faced, or she would confirm that some problems are simply too difficult for anyone to solve. The clock was ticking. Lisa stood frozen for a moment after Mr. Davidson walked away. 48 hours. 2 days to solve a problem that had stumped the company's best engineers for 8 months. Her hands were shaking as she gripped the cleaning cloth. What had she gotten herself into? Her father, Roberto, appeared from around the corner, pushing his cleaning cart. He had heard the entire conversation with the CEO. His face showed a mixture of pride and worry. "Mija, are you sure about this?" he asked quietly. "These are very smart people who couldn't fix this problem." Lisa looked at her father, the man who had worked so hard to put her through college. "Dad, this might be my only chance. If I don't try, I'll always wonder what could have happened." Roberto nodded slowly. He understood. He had spent his whole life wondering about missed opportunities. That evening, Lisa sat at her small desk, in their tiny apartment. She had borrowed every technical manual she could find from the company library. The kitchen table was covered with papers, diagrams, and her old engineering textbooks from college. She made a pot of coffee and settled in for a long night. The first thing Lisa did was read every single failure report from the past 8 months. Each report was detailed, showing exactly what happened during each test. The engineers had been thorough. She had to give them credit for that. They had measured everything they could think of: temperature, pressure, fuel flow, electrical systems, vibration levels. But as Lisa read through report after report, she noticed something strange. The engineers were so focused on the engine itself that they hadn't paid much attention to anything else. Every measurement, every test, every analysis was about the engine components. It was like they were looking at the problem through a microscope and missing the bigger picture. Around midnight, Lisa made her first important discovery. She had created a simple chart showing the exact time of each engine failure over the past 8 months. The pattern was clearer than she had expected. The failures didn't just happen around 47 minutes. They happened at almost exactly 47 minutes, give or take 30 seconds. This was too precise to be a coincidence. If the problem was with the engine design, the failures would be more random. Some might happen at 30 minutes, others at an hour, depending on how hard the engine was working. But this level of precision suggested something else entirely. Lisa grabbed her phone and started researching online. She read about similar problems in other industries. She studied cases where equipment failed in regular patterns. Slowly, an idea began to form in her mind. What if the problem wasn't the engine at all? What if something in the environment was causing the failures? The next morning, Lisa arrived at work with her father as usual. But instead of helping with the cleaning, she asked Roberto if she could spend time in different parts of the building. She wanted to understand how everything worked together. Roberto was nervous about this. "Lisa, if someone sees you wandering around instead of working, we could both get in trouble." But he could see the determination in his daughter's eyes. He decided to take the risk. Lisa started by visiting the building's maintenance room. She introduced herself to the maintenance supervisor, Mr. Chen, and explained that she was helping with the engine project. He was happy to show her around. Most people never paid attention to the building system, so he enjoyed having someone who was genuinely interested. "The building runs on a pretty sophisticated system," Mr. Chen explained as he showed her the control panels. "We have separate climate zones for different areas. The engineering labs need very precise temperature and humidity control. The manufacturing floor needs different settings, and everything runs on automatic cycles to save energy." Lisa asked about the timing of these cycles. Mr. Chen pulled up a computer screen showing the building's schedule. "Most systems cycle every 45 to 50 minutes, he said. "The air conditioning, heating, humidity control, they all work together to maintain optimal conditions." Lisa felt her heart racing. 45 to 50 minutes. That was almost exactly when the engine failures were happening. This couldn't be another coincidence. She spent the rest of the morning learning about the building's systems. The more she learned, the more excited she became. The engineering lab where they tested the engine was connected to the main building climate system. Every 47 minutes, the system would make adjustments to temperature and humidity levels. But why would this cause the engine to fail? Lisa knew she needed to understand the engine design better. She went back to the technical documents and started studying the fuel injection system. This was the most precise part of the engine, designed to deliver exact amounts of fuel at exactly the right time. After hours of reading, Lisa found what she was looking for. The fuel injection system was incredibly sensitive to temperature changes. Even tiny variations in temperature could affect how thick or thin the fuel was. If the fuel changed consistency even slightly, it could throw off the entire timing system. Lisa realized that the engineering teams had designed and tested their engine in perfect laboratory conditions. They had assumed that the temperature would always stay exactly the same. But in the real world, the building's climate system was creating tiny temperature fluctuations every 47 minutes. These changes were so small that the engineers hadn't even noticed them. The building's temperature might only change by 1 or 2 degrees. To a person, this would be completely unnoticeable. But to a precision engine designed to work within extremely tight specifications, these tiny changes were enough to cause complete failure. Lisa felt like she had solved a puzzle that had been missing a crucial piece, but she knew she needed proof. She couldn't just walk up to the CEO with a theory. She needed data, evidence, something concrete to back up her idea. That afternoon, while the engineering team was in meetings, Lisa borrowed some basic testing equipment. She set up temperature sensors around the engine testing area. She also found the building's climate control logs, which showed exactly when the system made adjustments. The correlation was perfect. Every time the building's climate system cycled, the temperature in the engine testing area changed slightly. And every time the temperature changed, it happened at almost exactly the same time the engine failed. Lisa was so excited that she could barely contain herself. She had found the answer. The problem wasn't with the engine design, it was with the testing environment. The engineers had created a perfect machine for perfect conditions, but the real world isn't perfect. But now came the hard part. How could she fix it? Lisa knew that redesigning the entire building's climate system would be impossible and incredibly expensive. There had to be a simpler solution. She spent that evening researching fuel systems and temperature control. She learned about fuel heaters, temperature regulators, and microclimate control systems. Gradually, an idea formed. What if they could create a small controlled environment just around the fuel injection system? Instead of trying to control the temperature of the entire testing area, they could use a much smaller system to keep the fuel at exactly the right temperature, regardless of what was happening in the rest of the room. Lisa did some quick calculations. A microclimate control system for just the fuel components would cost around $30,000. This was a lot of money for most people, but for a company that had already spent millions on the project, it was practically nothing. The solution was elegant in its simplicity. Instead of fighting against the building's natural temperature variations, they would isolate the most sensitive part of the engine from those variations. The fuel would always be at the perfect temperature. The timing would always be precise and the engine would run smoothly. By the end of the second day, Lisa had put together a complete presentation. She had charts showing the correlation between temperature changes and engine failures. She had research supporting her theory about fuel viscosity and timing systems. She had a detailed plan for implementing the solution, including cost estimates and installation timeframes. But she also had doubts. What if she was wrong? What if the real engineers found obvious flaws in her analysis? What if Mr. Davidson thought she was just a young woman with a college degree trying to show off? Lisa looked at her father, who had been quietly supportive throughout the entire process. Roberto had watched his daughter work with pride and amazement. He had seen her transform from a frustrated college graduate into a confident problem solver in just 2 days. Whatever happens tomorrow, Roberto told his daughter, I'm proud of you. You didn't give up when things were hard. You used your brain and your education to find answers. That's all anyone can ask for. Lisa hugged her father. Tomorrow morning, she would present her findings to Mr. Davidson. She had done everything she could with the time she had been given. Now she just had to hope that her solution was as good as she believed it was. The next morning would determine whether Lisa's 48 hours of intense work would change her life forever, or if she would go back to cleaning floors and sending out resumes. But either way, she had proven something important to herself. She was capable of solving complex problems, even when experienced experts couldn't find the answers. The investigation was complete. The discovery had been made. Now came the most challenging part of all, convincing others that she was right. Lisa barely slept that night. She kept going over her presentation, checking her calculations one more time. At 5:30 a.m., she gave up trying to sleep and got dressed. Her father, Roberto, was already awake, making coffee in their small kitchen. "You ready for this?" he asked, handing her a cup of coffee. Lisa took a deep breath. "I think so. I just hope I'm right about everything." They arrived at the building earlier than usual. Lisa had asked Mr. Davidson to meet her at 6 a.m. before the other engineers arrived. She wanted to present her findings without an audience first. If she was completely wrong, at least she wouldn't embarrass herself in front of the entire engineering team. Mr. Davidson was waiting for her in the conference room, looking tired and stressed. He had spent most of the night thinking about the company's future. The board meeting was scheduled for next week, and he still didn't have good news to share with them. "All right," he said as Lisa walked in with her folder of documents. "Show me what you found." Lisa's hands were shaking slightly as she opened her presentation folder. She had practiced this speech dozens of times, but presenting to the CEO felt completely different than talking to herself in the mirror. "Mr. Davidson, I believe I found the real cause of the engine failures," she began. "The problem isn't with the engine design itself, it's with the testing environment." She showed him her chart of failure times, perfectly aligned with the building's climate system cycles. She explained how tiny temperature changes were affecting fuel viscosity, which threw off the precision timing system. Mr. Davidson listened carefully, asking questions and studying her data. "This is interesting," he said after 20 minutes, "but how can you be sure this is the real cause? Our engineers have been looking at this problem for months." Lisa had anticipated this question. "I'd like to test my theory. If I'm right, we should be able to predict exactly when the next failure will happen. And more importantly, we should be able to prevent it with a simple modification." Mr. Davidson looked at the young woman sitting across from him. 2 days ago, he had barely noticed she existed. Now she was presenting him with the most convincing explanation for their biggest problem that he had heard in months. "What kind of modification?" he asked. Lisa explained her microclimate control solution. She showed him cost estimates and implementation plans. Everything was detailed and professional. Mr. Davidson was impressed despite himself. "Let's test your theory," he said finally. "If you're right, this could save the company." An hour later, the engineering team started arriving for work. Mr. Davidson called an emergency meeting and asked Lisa to present her findings to the group. Lisa felt her stomach drop. Presenting to the CEO was one thing, but facing a room full of experienced engineers was terrifying. The head engineer, Dr. Williams, was the first to arrive. He was a man in his 50s who had been with the company for over 20 years. He had multiple degrees and had published papers in engineering journals. When he saw Lisa setting up her presentation materials, he looked confused. "What's going on here?" Dr. Williams asked Mr. Davidson. "Lisa has a theory about our engine problem," the CEO replied. "I want everyone to hear what she has to say." More engineers filed into the room. Lisa recognized some of them from her cleaning rounds. They had always been polite to her, but she could tell they saw her as just the janitor's daughter. Now she was standing at the front of the room, about to tell them they had been missing something obvious for 8 months. Lisa began her presentation again, but this time the audience was very different. The engineers listened, but she could see skepticism on their faces. Some were whispering to each other. Others were looking at their phones, clearly not taking her seriously. When she finished, the room was quiet for a moment. Then Dr. Williams spoke up. "This is an interesting theory," he said, "but I have some concerns. First, you don't have any actual industry experience. Second, our team has already considered environmental factors. We've measured temperature variations, and they're well within acceptable ranges for this type of testing." Lisa felt her confidence wavering. "But did you look at the correlation between the climate system cycles and the failure times?" she asked. "Correlation doesn't prove causation," replied another engineer, Dr. Martinez. "Just because two things happen at the same time doesn't mean one causes the other. This could be pure coincidence." The discussion continued for another hour. Some engineers asked good questions about her data. Others seemed dismissive of the entire presentation. Lisa did her best to answer every question, but she could feel the room's skepticism growing. Finally, Mr. Davidson interrupted the discussion. There's only one way to settle this. Let's test Lisa's theory. If she's right, we should be able to predict the next failure and prevent it with her proposed solution. Dr. Williams looked uncomfortable. Sir, with respect, implementing an unproven solution could set us back even further. We have our own theories that we're still working on. Your theories haven't worked for 8 months, Mr. Davidson replied, firmly. We're going to try something different. The next few days were tense. Lisa worked with a small team to implement her microclimate control system around the fuel injection components. It was a simple modification that cost exactly what she had estimated, $30,000. Meanwhile, the regular engineering team continued their own work, clearly hoping that Lisa's solution would fail so they could prove their expertise. The office politics were uncomfortable. Lisa could hear whispered conversations that stopped when she walked by. Some of the engineers were professional and helpful. They answered her questions and provided technical support when she needed it. But others made it clear that they didn't appreciate being shown up by someone without proper credentials. Dr. Williams was the most vocal opponent. In meetings, he would point out Lisa's lack of experience and question whether her solution was really safe for such an expensive prototype engine. We're risking millions of dollars on an untested theory from someone who just graduated college, he said more than once. Lisa tried to stay focused on the work, but the pressure was enormous. She knew that if her solution failed, it wouldn't just be embarrassing. It could damage the company's most important project even further. Her father, Roberto, watched all of this unfold with growing concern. He had worked at the company long enough to understand office politics. He knew that some people were hoping Lisa would fail, just to prove that experience and credentials mattered more than fresh ideas. Maybe you should be more careful, Roberto warned his daughter one evening. Some of these people have a lot of power in the company. If your idea doesn't work, they might try to blame you for making things worse. But Lisa was determined to see her solution through. She had done the math, checked her calculations, and was confident in her analysis. The microclimate control system was installed and ready for testing. The day of the test arrived. Word had spread throughout the company that the janitor's daughter was attempting to solve the impossible engine problem. Some people were curious and supportive. Others were waiting to see her fail. Mr. Davidson, Dr. Williams, and the entire engineering team gathered in the testing facility. Lisa stood near her monitoring equipment, watching the temperature readings from her new control system. The fuel was maintaining a perfectly steady temperature exactly as she had predicted. The engine started up smoothly. 10 minutes passed without problems. 20 minutes, 30 minutes. Lisa could see the tension in the room growing as they approached the critical 47-minute mark. At 45 minutes, the building's climate system kicked in, just as it had hundreds of times before. But this time, Lisa's microclimate control system compensated instantly. The fuel temperature didn't change at all. 47 minutes passed. The engine kept running smoothly. 50 minutes, an hour, 2 hours. The room was completely silent, except for the steady hum of the engine. Lisa watched her monitoring equipment, hardly daring to breathe. Everything was working exactly as she had predicted. After 3 hours of continuous operation, Mr. Davidson called for a break. The engine was still running perfectly. Dr. Williams looked stunned. Some of the other engineers were studying Lisa's monitoring data with new respect. How long has it been since we had a 3-hour test run? Mr. Davidson asked the room. Never, Dr. Williams answered quietly. The longest previous run was 47 minutes. The test continued for the rest of the day. The engine ran for 8 straight hours without a single problem. By the end of the day, everyone in the room knew that Lisa had solved the problem that had stumped them for months. But success brought new challenges. Some engineers were gracious and congratulated Lisa on her breakthrough. Others seemed resentful that an outsider had succeeded where they had failed. Dr. Williams was professional but clearly uncomfortable with the situation. We'll need to run more tests, he said. One successful day doesn't prove that the solution is completely reliable. Lisa understood the need for more testing, But she also sensed that some people were looking for reasons to discredit her success. The politics of the situation were becoming as complicated as the engineering problem had been. Over the next 2 weeks, they ran test after test. The engine performed flawlessly every time. Lisa's solution was proving to be not just correct, but remarkably effective. The engine was actually running better than the original specifications had predicted. But with success came a new problem: what to do with Lisa herself. 2 weeks had passed since Lisa's solution had saved the engine project. The prototype was now running 24 hours a day without any problems. The company's biggest crisis was over, but a new question had emerged. What should they do with the young woman who had solved their impossible problem? Mr. Davidson sat in his office looking at the latest test reports. The engine wasn't just working, it was performing better than anyone had hoped. Lisa's microclimate control system had improved the engine's efficiency by 12%. This meant the final product would be even more valuable than they had originally planned. The phone on his desk rang. It was the chairman of the board. "Davidson, I hear you've had a breakthrough with the engine project," the chairman said. "The investors are very pleased. How did your team finally solve the problem?" Mr. Davidson paused. How could he explain that their breakthrough had come from the janitor's daughter, not from their expensive team of senior engineers? "It's an interesting story," he said finally. "I'd like to present the full details at next week's board meeting." After hanging up, Mr. Davidson realized he needed to make some important decisions. Lisa deserved credit for her work, but recognizing her success would also highlight the failure of his engineering department. It was a delicate situation that required careful handling. Meanwhile, Lisa was experiencing the strangest weeks of her life. Overnight, she had gone from being invisible to being the center of attention at the company. Some people treated her like a hero. Others seemed uncomfortable around her, not sure how to act around someone who had embarrassed the entire engineering department. Dr. Williams had been particularly distant since the successful tests. He was professional in meetings, but Lisa could tell he was struggling with the situation. After 20 years of being the top engineer at the company, having his expertise questioned by a recent graduate was difficult to accept. The other engineers had mixed reactions. Some were genuinely impressed and wanted to learn from Lisa's approach. They asked her questions about her analysis methods and seemed interested in her different perspective on problem solving. But others were less welcoming. Lisa overheard conversations that stopped when she walked by. She caught looks and whispers that made it clear some people thought her success was just luck. A few even suggested that the real engineers had done all the hard work, and Lisa had just gotten lucky with one small insight. Lisa tried to focus on her work, but the social dynamics were exhausting. She had never dealt with office politics before, and navigating the complex relationships was harder than solving the engine problem had been. Her father, Roberto, watched his daughter struggle with her new situation. He had worked at the company long enough to understand what was happening. "Some people don't like change," he told Lisa one evening. "And some people don't like being wrong. You made them look bad without meaning to, and now they don't know how to handle it." Roberto was proud of his daughter, but he was also worried. He had spent 15 years as an invisible employee, and he knew how quickly things could change in a corporate environment. Success could be just as dangerous as failure if it wasn't handled carefully. One morning, Mr. Davidson called Lisa into his office for a private meeting. She had been expecting this conversation but wasn't sure what to expect. "Lisa, I want to talk to you about your future with the company," he began. "Your solution has saved our most important project. The board is asking questions, and I need to give them answers." Lisa sat quietly, waiting to hear what he would say next. "I'm prepared to offer you a position as a junior engineer," Mr. Davidson continued. "You would start in our development department working directly on advanced projects. The salary would be competitive, and there would be opportunities for advancement based on your performance." Lisa felt a mix of excitement and nervousness. This was what she had dreamed of, a real engineering job with a respected company. But she also knew that accepting the position would be complicated. "What about the current engineering team?" she asked. Some of them don't seem happy about what happened with the engine project. Mr. Davidson nodded. That's something we'll need to work through. Change is never easy, especially in a technical environment where expertise and experience are highly valued. But the company needs people who can think differently and solve problems that others can't. Lisa asked for time to think about the offer. That evening, she talked it over with her father. Roberto was excited about the opportunity, but also realistic about the challenges. You'll have to prove yourself every day, he warned. Some people will always see you as the janitor's daughter who got lucky. You'll need to be better than everyone else just to be treated as an equal. Lisa understood this. She had always known that success would come with extra scrutiny, but she had also learned something important about herself during the past few weeks. She was capable of solving problems that others couldn't, and she wasn't afraid of hard work. The next day, Lisa accepted the job offer. Mr. Davidson announced her promotion at the weekly company meeting. The reaction was mixed. Some people applauded genuinely. Others clapped politely but without enthusiasm. Dr. Williams congratulated her professionally, but Lisa could see the tension in his eyes. I look forward to working with you, he said, though his tone suggested otherwise. Lisa's first few months as an engineer were challenging. She was assigned to work on various projects, always under close supervision. Some colleagues were helpful and supportive. Others seemed to be waiting for her to make mistakes that would prove she didn't belong. But Lisa had learned something valuable from her experience with the engine project. She had discovered that her outsider perspective was actually an advantage. While the experienced engineers focused on complex technical solutions, Lisa often found simpler approaches that worked just as well. On her third project, Lisa identified a manufacturing inefficiency that had been costing the company thousands of dollars per month. Her solution was so simple that everyone wondered why no one had thought of it before. The answer was that sometimes being too close to a problem makes it harder to see obvious solutions. Word of Lisa's successes began to spread beyond the engineering department. Other divisions started asking for her input on their problems. Mr. Davidson realized that Lisa's ability to see things differently was exactly what the company needed to stay competitive. 6 months after joining the engineering team, Lisa was promoted to senior engineer. This time the announcement was met with more genuine enthusiasm. She had proven that her success with the engine wasn't luck, it was a real talent for problem solving. But Lisa's biggest impact came from what she revealed about the company itself. Her success had exposed some uncomfortable truths about how they had been operating. During a presentation to the board of directors, Lisa explained how she had solved the engine problem. But she also talked about what she had observed during her time cleaning the building. I noticed things that the engineering teams missed because I was looking at the big picture instead of focusing on individual components, she explained. But I also realized that there might be other people in the company who see things that were missing. Lisa proposed creating a program to identify and develop talent from unexpected places within the company. Not everyone needed a college degree to have good ideas, she argued. Sometimes the best insights came from people who understood how things really worked day to day. Mr. Davidson was intrigued by this idea. He asked Lisa to develop a formal proposal for what became known as the Fresh Eyes program. The program would identify employees throughout the company who showed problem-solving abilities regardless of their current job title or educational background. The program was revolutionary for the company. They discovered that the maintenance staff had insights about equipment efficiency that the engineers had never considered. Administrative assistants had ideas about workflow improvements that could save significant time and money. Even security guards had observations about facility operations that proved valuable. Roberto was one of the first people selected for the program. His 15 years of experience maintaining the building had given him deep knowledge about how all the systems worked together. He was promoted to facilities manager and became responsible for training other maintenance staff. The father-daughter team of Roberto and Lisa became symbols of the company's new approach to recognizing talent. Their success story was featured in industry magazines and business journals. Other companies started implementing similar programs, but for Lisa, the most important outcome was personal. She had proven to herself that she belonged in the engineering world. She was no longer the janitor's daughter who got lucky. She was a respected professional who had earned her place through hard work and innovative thinking. 2 years after accepting the challenge to fix the impossible engine, Lisa was leading her own engineering team. She was working on next-generation sustainable technology that could change how the entire industry approached clean energy. Her team was diverse, including people from various backgrounds and experience levels. Lisa had learned that the best solutions often came from combining different perspectives and approaches. During team meetings, Lisa would often remind her colleagues about the importance of looking at problems from multiple angles. "Don't assume that the obvious answer is wrong just because it seems too simple," she would say. "Sometimes the best solutions are hiding in plain sight." The company had been transformed by Lisa's success, but the broader impact was even more significant. The story of how a janitor's daughter solved an impossible engineering problem inspired people throughout the industry to reconsider how they approached both technical challenges and human resources. Lisa's revelation had been simple, but powerful. Talent and insight can come from anywhere, and the biggest breakthroughs often happen when we're willing to listen to voices that we've been ignoring. The engine that had nearly destroyed the company became the foundation for a new product line that made Apex Industries one of the most successful clean energy companies in the world. And it all started because someone was willing to look at an old problem with fresh eyes.